Let's begin by looking at static methods, which we briefly discussed while introducing methods. While introducing methods, we said methods can be of two types. One is instance, while the other is static. Java is object-oriented, and so most of the time, methods invoked deal with state, that is instance variables. Such methods are the instance methods. But sometimes we also implement utility methods that do not depend on state, and such methods are defined as static. An example would be the min method from the class java.lang.math, which is a class that provides several utility methods for performing mathematical operations. Note that a class can have only instance or only static methods, or it can have both of them. Static methods have the keyword static in the method declaration. Absence of static keyword implies it's an instance method. Main method is an example of a static method. In fact, all the methods we wrote so far in our basics demo class are static methods. Static methods are class methods. That is, as mentioned earlier, unlike instance methods, they don't deal with object state. That is, they don't have access to either instance variables or instance methods. Trying to access them from a static method generates a compiler error. However, they can access static variables. If you recall, static variables are class level variables. That is, they are also not object specific. A static variable declared in a class is shared across all objects of that class. Since static methods don't have anything to do with state, they can directly access other static methods in the same class. Since they are class level methods, they can be invoked using a dot operator on the class name. For example, to invoke the min method in the math class, you would simply do math.min. And it would also save heap space as you don't have to create an object. Note that it is legal to invoke a static method on a reference variable, but it leads to misleading code as reference variables are associated with objects. So it's not recommended to invoke a static method using a reference variable. And even if you do, compiler would implicitly resolve it back to class name. Next is an effective Java item, and it is item 4. And it says enforce noninstantiability with a private constructor. Basically, if all methods in your class would be static, then you can make the class non-instantiable by marking its constructor as private. So if you make the constructor private, then no other code can create an object of your class. And that would also save some heap space. Java.lang.math is implemented this way, which means that we cannot create an instance of the math class. Let's actually look at this by reviewing the source code of the math class. Whenever I want to explore source code, I use this site called grepcode. I simply Google for grepcode and the particular class I want to explore. So let's do that. So let's search for grepcode and the math class. Let's just type in math. Here it is. So this is the first link. Let's just click that. And here it shows the code for math class. So basically, grepcode is a search engine that has indexed several libraries including JDK. And it basically allows us to browse through these libraries. For JDK, they index something called OpenJDK, which is an open source version of JDK. And it is almost identical to Oracle's JDK. So you should be able to explore this code without any assumptions. So let's just look at this math class that we have here. So it's the actual source code, and here it says OpenJDK, and it's one of the, I think it's one of the 6.0 versions, Java 6 versions, but that's fine. And let's click on this. This is the constructor. Here you can see the constructor and all the methods in the math class. Okay, so let's just click on this. Here is the constructor, and it says it has a private modifier, which means that it is non-instantiable, right? And here are all the different methods that we have. And here is one of the methods min. Let's just go ahead and click that. It's an overloaded method. And here is the static modifier, which means that it is a static method. And as we know, all the methods in the math class are static methods. And if you click this one, this down arrow, it shows as all the usages, all the classes that are using this particular min method. For example, string class is using the min method from this particular method called compare_to. And here we have another class called java.util.arrays, which is also using it in a method called sort1. Arrays is also like a math class. It has a private constructor, so it is also non-instantiable. And these are some other methods, some other classes that are using the min method. And that's about it regarding the grep code. So you can use it to explore any particular class that you want to explore. And you can also do one more thing. If you don't want to use this, you can actually search. I mean, the JDK that you have downloaded also comes with the source code. So let me just show it to you on my machine. So this is the root directory of my JDK, which is the JDK 1.8. So I just went into program files, Java JDK 1.8, and here you can see this zip file called src, and it has the source code. So you just need to unzip it. I have also done that, and I just extracted only one of the directories, which is Java. It has few other, the zip file has few other directories, but I just exported only one of them. So here it is the Java. So if you go into Java, so these are the different folders, like the java.lang packages here. So just go into lang, and then you can see all the classes here, and here it is, math.java, and I can just edit it, and it's the same thing. I can explore the code. So you can either do this, or you can explore the grep code's website. And that's about it.